I could tell myself to relax it. Will be better next time I try. And even if I still can't do it, yeah, you know that I'm gonna stick to it. Yes, it's all about going through it, and I'm gonna tell you why. Whoopsie, whoopsies, I made a mistake and it's okay. It's okay. Whoopsies are what it takes to get better and better every day. Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see I'm better at this today. Woo! Whoopsie, 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 whoopsies.
I'm a little embarrassed when I look at my drawing compared to this. I'm just not getting anywhere with this. It makes me wanna hide. Aw, don't be embarrassed. Don't hide.
You should have seen mine the first time I tried. It took a lot of whoopsies to look this way.
No one's perfect on their first day. Whoopsie.
Whoopsies, I made a mistake and it's okay.
It's okay. Whoopsies are what it takes to get better and better every day. Whoopsie, 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 whoopsie.
Well, what about this? I want to jump rope, but nope, I just can't do it.
Well, not yet. Come on and practice with me. You'll see there's nothing to it.
Whoa! Whoopsie.
Whoopsies, I made a mistake and it's okay. It's okay. Whoopsies, help me look, see I'm better at this today. Woo!
It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. I know it's hard, but for long, before it's too late. Wake up, my love, please don't give up on me. It's hard. Wake up. It was only a dream, the waves of evil crashing over us. It was only a weak and faithful scream beneath the battlements. But I know it's hard before long, before it's too dark. Wake up, my love, please don't give up on me.
What is up? What is up, you guys? We are back at it again. Another day down. We are almost at the halfway point. I hope y'all are hyped because we're this close from the halfway point. We're getting, I can smell it, all right? Oof, it smells good. I hope y'all are feeling good and feeling like you might have learned at least one thing throughout this, all right? One thing, one new thing, all right? Hopefully. So let's go ahead here and finish up with our intro. If you guys didn't know, we are Rootkit, a non-profit based here in the US of A. Let me go ahead and switch over this music here. There we go. We are non-profit based in the US of A. If you go over to our site, we like doing a lot of free stuff. Not just this class, which we're giving for free, which if you go to college, you'll learn literally everything the exact same plus more. Except you're going to have to pay $100,000. Just don't do that. Just come here, get your cert. All right, and then you can get a job. Or if you rather go to a boot camp, I mean, you can pay us $20,000. I mean, we are a boot camp, all right? We're better than all of the other ones because they're claiming they're going to teach you in like 8 to 12 weeks. That's impossible, all right? Especially now that you guys have been attending these days, you should know that's pretty impossible, and we're going at a very fast pace right now too. So on top of all that free info we're giving away, if you go over to our blog, we're giving away free merch. All right? If the site will ever load, God, someone tell whoever's in charge of the site to make it faster. Lazy people, that's all I gotta say. Week 6 giveaway. You got 23 hours left to enter in for a sweater. It's completely free. All you have to do is basic things like sub to our YouTube and our Twitch, all right? Basic thing, completely free. If you like what we're doing and you want to help support our mission, because doing things for free is not cheap, not at all. You can go over to this page, which is in the description of the YouTube video and also on Twitch in our bio somewhere on there. You can donate, and depending on how much you donate, you can unlock certain rewards, like our epic stickers, this epic super cool collab t-shirt here, and exclusive 100-day Rootkit sweater, which I absolutely love. Additionally, all donations are being matched 1-for-1 for the first 10,000, so you make sure you go donate. It's like you're donating twice as much. And we have pillars to hit along the way, like streaming for 24 hours straight, shaving my head here live on stream, and the one no one wants to see, so we don't need to get there, and that's shaving my beard. All right, no one wants to see. We don't need to go there. All right. Alrighty, let's see here. Also, if you are a Patreon or Discord premium member, all right, please come to the events chat, all right, or the events voice channel. I'm in there right now. You don't have to be with the rest of these peasants in chat typing. God, peasants. All right, typing's for losers. That's why oh crap, I type all the time. Never mind, I recall that statement. But you can join in there if you want to talk to me directly throughout the stream at any time and ask questions instead of type in the chat. Additionally, you get access to the supporter chat, which is where we're dropping pretty much every day our code that we've coded through with lots of comments and documentation. There is a 1-week free trial of Discord Premium on our Discord, so you can go and do that if you want to see what is up in the supporters chat. All right. Alrighty. Any questions you guys got before we get into it? All right, because we've been chugging along. Now remember, Sunday is our chill Q&A day. Sunday is our chill Q&A day. That is where we can go back and answer and reteach any concepts and answer any questions that you guys might have had along the way. We can, as we've been going forward, we'll answer questions through the day, but that varies on, how in depth we can go, especially if we've already covered it before. But that is your day to come back and shine. Let me check out here. Choo choo. Catch up day. We're moving super fast. Let's go. I like it. You guys sound like you're hyped up. So let's finish up our game. I hope y'all are seeing this. Okay, so I put something in the chat the other day. yesterday, not the other day, literally yesterday, because I tricked all of you. You guys are all fooled, idiots, all right? I'm here to destroy you, all right? I've actually been secretly programming your mind to do math. You didn't even know. We saw some minus signs, but you didn't even, not just any normal math. I got you to do calculus, idiot. Oh man, what a fool you look like. You did calculus, freaking nerd. You didn't even know it. God, if you didn't see it already, if you go in the 100 days of chat, rootkit chat, this basically sums it up. This is calculus, all right? This is calculus. There, you will see this all the time in formulas in calculus. It's essentially a for or a while loop. It's a while loop if it goes to infinity here at the top, and it's a for loop if it goes to a certain known end. The only difference is this is going to be doing some type of calculation over time. For example, maybe you wanted to watch trends in the stock market, or you're making an XP system in your application. You can now, we'll go forward, doing our loops as normal, but now you could potentially peek over to math and maybe see what the algorithms they've used on other games like Pokemon, etc., because usually they'll be in math notation, all right, like a calculus notation, kind of like this, and you should be able to at least kind of decipher it, all right? But yep, joke's on you. You've been learning calculus the whole time. Man, I got you guys good. That's all I gotta say. It's a good thing they don't teach programming first in school and they teach just straight up math, because that's so much of a better and easier method, right? Instead of making a game and then and then teaching you that it was math all along. All right, let me go ahead and get rid of some of these comments here. Oh boy, you guys just saw what all the paid members got. Better write notes. I gotta remind myself to erase those before we get on stream, all right? Now I'm losing value for my Patreon members, all right? All right, are you guys ready? Said clip it. Oh, I've been bamboozled. Clip it. Oh, don't clip that. Don't clip that. That's going to be controversial. We don't want to reveal to the world we tricked a bunch of random people watching us on YouTube into learning calculus and they didn't even know. That's going to be a bad for our image. Trust me. All right. Everything's controversial nowadays, especially learning math. All right. So a lot of you guys did a great job for your turn-ins on your documenting your code and kind of just trying to reinforce what we went over, which I like, which I really, really like. And it's really, really good, because the only way a lot of this will continue to click for you, because I can't, some of you guys in here, this will click immediately, all of this, and this will just kind of make sense to you. Some of you guys, if you're like me, it's going to take quite some time, all right? Because I'm a little stupid, all right? So it's going to take you quite a little bit more time. Documenting, putting comments in, and retyping out things, maybe from scratch, challenging yourself to remake it from scratch. Great ideas, great tools. Definitely do it, all right? Because that repetition is going to really enforce it, all right? Really enforce it in your brain. There are no cheat codes to life. There's only trekking forward and making it to the top eventually. You can't really just insta-win, all right? And I'm not going to talk about the exceptional 0.0000001% of people, all right? The 1%ers that made it as the 1%ers in the US, there's no cheat codes, all right? All right, let's see here. So we got our program here. It's doing good. We're making our customer happy, all right? Because we're showing progress. We're trekking along. We're showing that we are competent devs and we can definitely make this game and turn in this product and make $1 million, all right? Or sorry, 100,000 V-Bucks. That's what I said earlier, right? So again, we got our word list here. We're choosing a random word. We're making a mask that's going to be the length of the word, and it's going to have falses for every single character, so they're correlated. To keep this correlation going, so everything's synced up, we're doing an enumerate here when we print stuff on the screen, so we can print the character of the word and get the location it is in the array. And that way we can match it up with the corresponding value in the mask. And then we'll be printing either the character or an underscore, depending on whether they've guessed it or not, or correctly or not. And that would change the mask. So next we're getting the user's input. We're sanitizing it for bad input. Now, we need some logic here now to switch over the mask, all right, to do some flippy floppy here of falses to trues, all right, to falses, from falses to trues, so we can mark when people do a correct word. Now, before we move forward, we do have some randomness going on in our game right now. Every time, it would be really easy for us to do our testing if we knew what the word was every time, so we could test this kind of logic. So let's go ahead and just temporarily, let's copy this and comment it out and just make it so our selected word is just going to be, I don't know, let's go with process. All right. So it's just the same thing every single time. So that way we don't have to also guess ourselves, add extra time. You know, we're lazy. We don't want to do extra work if we don't have to. All right. All right. Any questions so far? All right. Good. Good, good, good. All right. So now we're always choosing the word process. We know at this point where my cursor is, they will have good input. Or do we know? We'll see here in a second. They should have good input. All right. Good input. So we'll only have one character, and we need to find if that character is in the selected word or not. All right, we need to find if that character is in the selected word or not, and then if it is, then match it up with the mask that corresponds, and then bammo whammo, they win or they lose. Or do the flipperoonie. So there's a little bit there, and let's try to unpack it a little bit. You know, one little bit at a time. We know we need to analyze the word, the selected word, and see if that character is in it. All right. This could send you on a Google search potentially to try to find out if there's a way to search through a string. An alternative way to do it is a for loop, because we've already used a for loop before here and here to go through character per character per character of the selected word. And specifically right here, we've done it to match up the mask. And we know we need to eventually change the mask. So, you know, it's never bad to have more information than none or less. So let's just grab this, and maybe it seems like the enumerate may become handy. I don't know. We'll see here. So let's go ahead and grab and steal our own code over here and paste it down here. All right. No parentheses around process, but quotes. Yes, because this is a string, because this was an array, and we're getting one value out of the array. So we got to use brackets to get one value out of the array. And that's going to be a string at the end. That's going to be one of these guys. So if we're not doing this logic, we're just going to grab process raw. All right. So let's see here. So we know we need to go through the character. All right. Go through the word character by character and try to see if that character is what they guessed. Sounds like an if statement there. So maybe we should type an if statement here. Let's try if the character they guessed, if it's equal to the character of the word, then we should do something, right? We should change the mask, right? We should definitely change the mask. So let's go ahead and we can write that if statement, and now we can just change the mask. That should be as easy as mask. We can steal our code right here. Mask, and we need to have it synced up so we can use that index. So that came in handy right there. So we need to know the correlating mask item that correlates with this character, and it's all false by default. And when they guess correctly, we're gonna want it to be equal to true. Sorry, not equal, just one. We want it to be equal to true. So that way we can flip them around, right? All right. This seems like a step forward. This is enough stepping forward. I think we should run this and try it out a little bit. So I get some questions here. So just to clarify, the mask prevents the character the user guesses from appearing in the terminal in the first mask. Correct. So the mask here, let me pull up my paint again, and I'll pull up the two examples. So we got our photo masking example. Holy crap, that is zoomed in. Where's the really good example? There we go. So we got this example. Let's see if there's another example we can use this time. Where's the, okay, I gotta zoom out more. Man, what do photo people type in order to, they're kind of rough for being a photographer nowadays. I guess there's this one right here. So this is what we're essentially doing. We have our raw word right here, and we have our mask. Our mask is going to be, instead of black or white, it's going to be true and falses. And wherever there's trues, aka the white transparent parts, that's where the characters will shine through. Whenever they're falses, you won't see the underlying color. All right, so again, over here for our little pretty picture that I wrote the other day, let's say our word is pool. That's our word. We're going to make a mask which is going to have falses for every character, and it's correlated. All right, so it's correlated. There is no actual correlation per se on the Python language level. We are implementing our own will, our own correlation upon it by making sure that when we use a certain character here with a certain index, like 0, 1, 2, and 3, that we need to make sure the corresponding indexed false or true here is going to change also. So that's all that's going to be going on, and by default, when a false is present, that character will not print. But if that false ever turns into a true, that character will print out. So that's how our mask is working here. Okay, I got you. Yep, just making sure and clarifying. So let's go ahead and minimize this. So this should work for flipping things from true to false when we have a correct character, right? When we have a correct character, how do you signify what's true and false? So right here in our mask, this is how we're making our mask, and we're signifying a false with the word false, capital F. Remember, capital F. And to do true, it's going to be a capital T. So let's go ahead and run this, and let's see if it works. All right, so give a character. We know we're using the word process now because we have it hard coded. We have it here hard coded in. That means that it's not being randomly chosen anymore. It's going to be static. It's going to be the same, unchanging. So we know there's going to be an O in there. So let's type an O, that's a 0, and press enter. And what do you know? The O worked. Our mask worked, and it's flipping. Our logic is sane, it's sound, it is working. If we do an S, we should see both of the S's show up. That's pretty neat. That's pretty neat. Let's try to finish the rest of the word. P, R, C, and whoops, I fat fingered a couple characters. I press enter. Looks like bad input worked, and looks like our our stuff's moving along here. Huh, no bugs so far. This looks pretty good. We got our game. This should be the win sequence. This should be, I have just won the game. So that is pretty cool. All right, we are chugging along here. We just need to now add some rules into the game because we don't want people just to do it and they're still playing the game. It doesn't actually end. We need rules. And remember, there's nothing in the beginning. There was nothing. All right. You are the god of this program. There is nothing at the beginning. You have to implement every little thing. So all the rules, we got to program them in. Let's see here. Process, guess a character. This is how. Yep, that's fine. Oh, it doesn't hide it by default. Make sure you have your mask being generated with all falses first, and that you have the correct logic here. Right? That you have the correct logic here. You should have been testing it yesterday after the class and making sure everything was working correctly. All right. So let's chug along here, shall we? So we got our flipperoonies going on, but we know we want to have some lives. All right. We know if they're guessing things wrong, we want to be deducting against their tries. What visual coordination we have going on doesn't really matter too much. It's more so they have attempts or tries or however you want to label it. I think kind of like the word attempts a little bit better. So before our main game loop here, let's go ahead, maybe after selected word, let's make something called attempts. All right. Did I spell this correctly? Let's see. Let me check. Oh, close. Attempts. There we go. And let's say we want to we got to test this logic. So let's just put it to like 2 for right now so we can do testing really quick. All right. So we want them to have 2 wrong attempts. So this, I guess, 2, we'll just call it attempts. Should we? Is there a better word? Any ideas for a better word? Attempts. We'll just use attempts. This is how many times they can get something wrong. All right. So I'm not happy with it. We're going to move forward with it. All right. We don't want to be stuck on it. All right. 2. So they're allowed to get 2 things wrong. All right. Or get things wrong twice. All right. To get things wrong twice. So if they get something wrong, then this will never happen. Something will never be set to true. So how could we go about tracking this? All right. Any ideas? Any ideas at all? This is where the creativity comes into place. All right. Because we need to track whether they've actually guessed something correct or not. And if they didn't correct anything or guess anything correctly, then they need to lose their attempts. For loop. Put a time limit. No time limits. We're doing based off attempts, so we don't need time. But you could add a time limit per guess. You could totally do that. For loop. Kind of on there. You're kind of close. So let's think about it a little bit. If we had an array here, let me go ahead and don't save. And let's go ahead and say we got our array here and it's all falses. Because this might be the first thing you think of. And this is where logic comes into play. And you really just got to keep practicing this until it clicks. All right. Until it clicks, until you get into logical thinking. All right. So everything's false by default, right? We could, right? It might make sense at first to be like, okay, I'll just look at the array. And if anything changes to true, then it was good. And if nothing changed to true, then if I'm looking at the array only, then they must have messed up, right? That would work for maybe the first time. But if this was true right here, and we went and looked through the array again, something would already be true. And if they got this one true, then that logic wouldn't work, because we would have seen there's already a change and it would have gotten messy really quick, and it just seems like such a complex problem at first. Usually if things seem overly complex, they're not. They're usually not. Usually things can be solved relatively simple. All we need to do essentially is make a tracker, right? Make something that tracks and tells us whether this run was a successful guess or not, right? And we already have the logic right here, the if statement, for tracking whether something was changed or not, right? So we couldn't just make a little variable here called our truth tracker, all right? Our truth tracker. And we can by default set this to false. So AKA they messed up. They didn't get something wrong. They got something incorrect. All right. So we can make our little tracker right here and have it so this tracker, whenever they get something correct, it goes to true also. So it can signal to us that they guessed something correctly. And we could have some logic down here on then verifying whether they got something wrong or not. So we could then have an if statement here for if the truth tracker, so if the truth tracker is true, that means they had a successful guess. But we want to see if they guessed something wrong. So we need to do the opposite, because ifs will only run when things are true. They like the truth and nothing that's wrong. So we got to flip this and do the opposite essentially. Now you could do the opposite by doing the opposite here, but it's a little bit confusing. So it's best to just do a not right here to get the opposite, to get the wrong version or the flip of it. So now we can say attempts equals attempts minus 1. So if the truth tracker is false, which means they didn't get something correct, we're going to flip that false around into a true. And if this is true, that means that we need to subtract 1 from their attempts, that they got a wrong guess. All right. So we're doing that. Awesome. Also, it'd be probably good if we print out our attempts onto the screen, because you might want to know how many guesses you have left. So we could just print here at the very beginning of our loop, print attempts, but just a number being there might be a little weird. So we can use that nice little format to make a little string here that says you have blank attempts left. And then we can do our dot format and put our little variable right here, so that way it looks a little bit nicer. So now if we run this, you'll see that it says by default we have 2 attempts left, and it should be tracking our wrong attempts. We'll try that here in just a second. Let me check chat, make sure everyone is okay, not dead. So go ahead and if you have any questions, go ahead and ask them. I'm going to just run this with a wrong attempt so we can see it subtract our wrong attempt, so like a Z. So now you'll see it says 1 attempt left. If I do a Z again, 0 attempts left. The game doesn't end because we don't have any logic for that right now. Well, that's okay. We'll add that here in a second. You guys have any questions on that? Scroll up. Just give you guys like another minute or so to catch up, try things on your computer, see if things worked out or not before we chug along here. You don't need to place that anywhere else. You only have one attempts variable, so you only need one of them to come through, to shine through the and get added to the string. You got to remember, you got to format it. You can't just do the brackets. You got to add the format to it. Any other questions before we chug along here? All right, so we're getting pretty far. We're getting pretty good. We just added, with just a couple lines of code, a way to flip-a-rooney our mask and have the correct character be revealed. Additionally, we made a little tracker here to track whether or not, their attempt was wrong or not. All right. We don't want this in the for loop. All right. We don't want this in the for loop because this will, if this was in the for loop, this would pop off every single time we looked at a character. That's no bueno. We just want to look once for every attempt. So we're going to add it not in the for loop, but outside the for loop. But some of you guys may have found there's a little bit of a bug in our code right now. All right. So for example, if we rerun this, let me cancel the last program, clear, and we rerun this, and if our first attempt was wrong, we went down 1, which is okay. That's what we wanted. But if our second attempt is correct, interesting. I guess that corrects it. Can I show what's another way I could show this bug? Here we go. Let me go ahead and rerun this. Here's another way we can see the bug. If I do a P and press, sorry, not a P, a Z, press enter, our attempt was wrong. And if I enter in something invalid like F and G, which is invalid, you'll see our attempts actually go down. And if I press have nothing in there, I press enter again, our attempts went down. We don't want to penalize users for their bad input, only for when they're actually wrong when playing our game correctly, right? So this is a bug that we need to fix. So how do we go about fixing that bug? Because we know right here, if they gave us a bad input, we don't want them to continue forward with this logic. So the first thing some people might think of is maybe throw an else right here and put this all up inside of the else. You wouldn't be wrong. That would work. That would work 100% successfully. That would fix the bug, because now if they are wrong, there's no extra code that gets ran here at the end, and they'll go back up here to the beginning of the while loop. And if they are, if they did enter in correct input, they'll instead go right here, and they'll continue playing the game. The only issue here is that we're gonna have a lot of tabbing upwards. As you can see right here, we're 1, 2, 3, 4 tabs up. Now, having things dented up really far is not an issue or a problem within itself. but sometimes it can be a hint or a clue that your logic may be wrong, or there may be another way that's better to go about it. So a better solution is if we kind of think of the question, oh no, what have I done? Is there a way to force or a loop to go back to the top? Instead of continuing forward to the end like it normally does, be like, no, go to the top right now. Just do it right now, all right? Don't ask any questions. I know there's more code later on, but I want you to go back to the top of the loop right now. Don't look at what's below. And the answer would be yes. There is a way to do that. There is a way to do that. There is a special word we're going to learn right now called continue. All right, called continue. Now this is implemented in just about every language. All right, what does continue do? So we'll put continue right here. Continue is a special word which is meant for usage within a loop. It could be a for loop or a while loop. What it will do is modify the looping behavior. So normally when we are looping, we're going to go from top and read everything. It's going to read everything, process it, keep reading, processing, and go all the way to the bottom. And then it's going to loop back all the way to the top and do the whole thing over and over again. All right, it's going to just keep doing that, go back to the top and over again. If you ever hit a continue, what will happen instead is it will at first read like normal, go down and down, and if it actually hits and sees this continue, it will say, oh, all right, I'm going to ignore everything below and I'm just going to go straight back to the top. All right, continues are a way to force your loop to stop going down and go straight back up to the top. It's very, very useful. So now when someone enters in bad input, all right, bad input, it will immediately send them back to the top of our game loop and have them retry entering input without penalizing them. But on top of that, without running all of this logic here, which also takes compute time. All right, so technically this is making our program faster than if we ran through all of our logic. All right, so continues are very, very, very useful. Don't forget them. You're going to use them a lot. There's also one extra special word we're going to learn here in a second. All right, continues the first one. Any questions on that? Hopefully that also gave you guys enough time to catch up if you were trying to catch up with the code. So now if we restart our program here and we do a correct input of like Z, press enter, you'll see we've decremented down 1. The number's gone down 1. But now if we do an incorrect guess like a 0, it tells us that the input was bad and we're back at and it didn't decrement us because the continue is saying, hey, while loop, halt right here and go back to the top. So now people can enter in bad input and it won't affect their score. They'll be safe. All right, they will be safe, which is good. That's what we want. So epic, epic, epic. So we can continue now further down our programming. So what's the next step we should take here? We got input from the user. Things are printing out correctly. We're flopping words. We have our truth tracker, all right, to tell us whether we should decrement their attempts or not. What is next? I guess it would be the win screen or the lose screen. I think the lose screen would be easier, right? If they lost, that would be easier, right? Since we already got that in here. We already got attempts in here, and so we can track losing. So maybe it's time for us to modify this while loop now. Because right now it loops forever. But now we know if their attempts are 0, they've lost the game, and we shouldn't be playing the game anymore. So let's modify this game loop here to see if the temps are 0 or key. So we want to do the opposite of that, because we want to loop forever until the attempts are 0. So while the attempts are not equal to 0, keep playing the game. And if the attempts are 0, then this will stop looping. So if we go here at the bottom and do a print, we can say you lost. And this hopefully should work. Let's run it and see. So let me close the game from before and rerun this. I'll do a 0. That's bad input. Let me do a Z and another Z. The game has stopped and it says we lost. That worked. That worked. That's pretty good. That is pretty good. Any questions on that? Yep, exactly. The attempts go down, but the game doesn't end. So we got to add that logic in. Because programming languages and computers by default are really, really dumb. All right, we got to tell it everything. We got to be very explicit. But the thing is, computers will do exactly what we tell them. Exactly. So if we tell them bad logic, all right, then they will do that bad logic perfectly, which may not be what you want. So that comes into the hardships of programming. Caught up but following long enough. But then what is the point of having a certain number of attempts? The point of having a certain number of attempts is we only want them to guess a word for X amount of times. So let's say 2 times. If they get 2 wrong guesses, the game's over and you didn't win. If they are able to get the word in 2 guesses, then they've won. That was before you made the print. Oh, okay. All right, perfect. So hopefully everything's making sense now. So now we're tracking losses. We're tracking when they lose. All right. This is pretty much a ready to go game if you always just want to be rewarded for losing. All right. Now we should probably take the next step to do winning. So how would we track if they're winning or not? Well, we have a mask, right? And by default, everything in that mask is going to be false. And if they guessed everything correctly, it should be true, right? Instead, everything in there should be true. So that might be a way we can go about doing it. So how can we track if everything is currently true or not? Or I guess do a check, all right? We have a check right here for bad attempts. So we should add another check here for whether or not they've guessed everything correct already or not. So there's, I guess, a couple things that might come to your mind, like a for loop, because we want to check every item, right? Every item in the mask to see if it's true. So I guess that makes sense. Does that make sense to you guys? That is definitely one way to go about it. I think that would be the most visually appealing. So let's just go with that way. Yeah. So let's just do a for loop right here to check if every single item is true or not. So let's do for item in a mask. So every single item in the mask, we want to check if it's true or not. If it's true or not. So if item, that will tell us if it's true or not. So if it's true, then we're happy. Well, we want to, well, yeah. So if it's true, then we're happy. If it's not true, then we're not happy. All right. So maybe we should put, by default, we're always happy. And then in here, maybe just be tracking if something is false. If it's not false, then we're not happy and we should maybe do something. Let's see here. This seems like maybe we need another tracker. Potentially another tracker. All right. Because if we have something that is wrong, if we have something that's wrong, or if the game's not complete, we need to like announce that somehow, right? We need to tell the rest of the game to end or not to end, to keep playing or not to keep playing. Oh, let's see. So maybe another tracker is the best way. Maybe we should also maybe Google something to see if there's just an alternative we can check up on and see if that alternative may work for our case. All right, because we got a lot of trackers here, not because anything's wrong with trackers, but let's just see if there's another alternative here for Python. All right, so let's bring up our Googles and let's say Python check if, because we want to check essentially if everything in the array is one value or not, right? If it's all trues or not, right? That's what it kind of boils down to. So let's see, Python check if all values in a list are equal. That seems about right, right? Check if all elements in a list are identical. That seems about right, right? So here's the question. Output's true or false, all right? Seems pretty close to what we were doing. So let's see here. They're doing things with this iter tool. Looks kind of complex. All right, looks kind of complex. So let's go ahead and go down here a little bit further and see what's going on. Looks kind of complex. So let's go and check the next item if there's some clarity here. Input, all of them are geeks. Output, yes. Input, they're not all geeks, so output, no. So how are they doing this logic? Well, this looks pretty close to what we're doing here. And look at that. There's a tracker. Their tracker is called check. They're doing a for loop and they're going along, not this again, and they're tracking whether everything's good or not, and then they're going to set this to false if things are not good. They're also using this new term called a break, all right, which we're about to get into here in a second. Let's see if there's another way to go about it. The other way to go about it is using this all method, which we have not talked about yet. So there's an all method we could use. The other way to go about it is using this count method, right? By using this count method. Interesting. There's a fourth way to do this. And here's the fourth way to do this. There's a fifth way to do that. The point is there's lots and lots of different ways. Oh, and there's a sixth way to do it. A seventh way to do it. There are a lot of ways to do potentially the things you want to do. Each one will come with pros and cons. It's totally up to you on what you want to do. And you got to accept the pros and cons. Some of these may be faster or more efficient than other ways, but they will all work in the end, and that is all that matters. Me personally, I would most likely do the count method or the all method because it's pretty much one line. So it's a lot simpler, but we're going to go take a look at this one right here. All right, because this one seems exactly what we're doing so far. We know what for loops are. We know what if statements are. We've done tracker logic before because we did it in our code already. So let's just, I guess, I don't know what break does, but let's copy it and see what happens. I don't know. We can just run the code and figure it out along the way. There's no harm in doing that. So let's just go ahead and do that. So if we go over to our code here, we know we need another tracker here for whether they've won the game. So let's just make another one called, I don't know, the winning tracker. All right. And we'll set this to false because they're not winning the game right now. They haven't won the game. So let's just set that to false. Let's go down here. And we know that if they win the game, this should now become true. So we could also, before even modifying this right here, we could modify our while loop right here to end the game if the winning tracker is true. So right here, we'll do an or because we don't want them to be out of attempts and win the game at the same time. We want to end the game if they've ran out of attempts or they won the game. All right, or if they won the game. So if we put our winning tracker here, we should be good, right? Well, remember, read this out loud to confirm what you're doing. All right, read it out loud. All logic, read it out loud. So we want to keep looping forever while their attempts have not equaled 0 or they've won the game. We don't want to keep looping if they've won the game. So we want to do the opposite of that. We want to keep looping if they haven't won the game. So we'll say not. So let's read it again. Keep looping forever while their attempts are not equal to 0 or they have not won the game. Seems good to me. We want to keep looping for that. So let's go with that and let's see if that logic ends up working. Always say your logic out loud, all right? It's going to help you understand what's going on. So if we go down here to our mask, we want to change this if they've won, all right? If they've completely won. If not, we want to keep it false. So for every item in the mask, so those are the falses and trues. If one single one of them is not true, if any single one of them is not true, then we don't want to we don't want to mark them as winning. So we could add that special thing here called break. Else, that means they are winning. That means things are good. Then we want to set them to winning. They're winning to true. So what's going on here? What is this break thing? Why are we talking about it? Do you guys like breaking things? Have you been tempted to break your computer yet? You can break things in software if you want, using the keyword break. Break is a way you can forcefully break things in your programming. By break, I mean you will forcefully break out or end a loop. So what loop are we ending? Break will be applied to the first loop that's closest to it, aka this for loop, since it's inside of this for loop. So what's going to happen here is if something is false, then we are going to immediately stop doing a check if they won the game or not. All right? Immediately stop doing a check if they won the game or not. Else, so everything is good and true, we're going to set the winning tracker to true. There is a bug right now in this code because, for example, let's say the first letter was guessed correctly. When we look at the first item in the mask, that will be a true because the first letter is correct. So that's true. So this will not run. And then we'll get to this one and it will run and it will set the winning tracker to true. Then it's going to go back to the top and go to the second character, which has not been guessed correctly. When we get to the second character here, it's going to hit here and see if it's a false or not. It is a false. So it's going to immediately stop this loop. When it stops this loop, it's just going to continue down the code here. And once it hits the bottom here, it's going to hit the top and be like, oh, your winning tracker is true. Uh-oh. They didn't win the game, so we should definitely need to fix that. So it's an easy fix. We just need to put in here, before we break out of this loop, setting the winning tracker to false. All right, setting the winning tracker to false. Additionally, the pro gamer move would be, I'm not going to remove this moving forward, but you could just remove the else here, because this code will never run, because this will, if something is false, this will forcefully break out of it and it will never hit this code. So by doing this, you're already in an else like state. But that's like the pro gamer move. You can just keep it like this. Right? You can keep it like this so it makes a little bit more sense. All right. Let's see. Are there any questions? We're not going to add any more code, but what we're going to do is we're going to just test this real quick. We're just going to test it real quick. So how we can test this is use print statements. All right, use print statements. Print statements are your best friend for making things fun for the user, but also for logging and for debugging. What does debugging mean? Debugging means figuring things out, figuring out bugs, typically. When you're not figuring out a bug, technically it's just called logging. All right, we're just going to call it debugging. It's going to be one of your best debugging tools. What do I mean by that? Well, maybe we want to see whether this logic is actually running or not, and whether it's running successfully or not. So what we can do is we can put print statements in here and be like, setting win tracker to false, then breaking out. Print here, set winning tracker to true. All right, you could add print statements anywhere. All right, we could add right here that this is for checking if the character was correct, and we could say right here they guessed a character correctly. Right, you can add as many print statements as you want to anywhere in your code to help you track and figure out what the hell is even going on in the first place. It can also help you debug things. So for example, if we don't know if our logic here is correct or not, we could, at the beginning of this loop, print the item. So we can see when the item gets printed, that should be true or false. After it gets printed, either this print statement or this print statement will be printed out, and it will tell us whether we entered this if or entered this else, and we could test our logic here. So now if we run this, you're going to see a lot of extra printing going on. Let me end this program clear. All right, we have 2 attempts. I'm going to guess an attempt correctly. I'm going to guess an O. So we saw here that they guessed a char correctly. We did guess one correctly, and that printed out once. Why did it print out once? So if we look here, they guessed a char correctly. Why did that print out? It printed out in this. It looks like we're looping over our selected word, and if the user input, what they entered in, is equal to a char, okay. So this is if they guessed a character correctly, which is what this print statement says. We can kind of see what logic it kind of corresponds with. Next, this says false. All right. And it only said false once. Interesting. So if we go here, we can see our loop and where we printed false. And then it says setting win tracker to false, then breaking out. So it looks like our program worked correctly. All right, it saw the false there, and then it went to this if statement, and then it went to the break here, and then it broke out. How do we know it went to the break here? Well, let's just put another print statement right after the break. Right here, and let's say, did you break out? Question mark. This should technically never, ever, ever print. Let's see if it does. All right, let's enter a program, rerun it, and I'll type in an O again and press enter. And it looks like this did not print out because, like I said, a break will forcefully end this loop. All right, this will end this for loop. The closest loop to it, it's going to end. So that worked well. So this is way, use print statements. Please use print statements a lot throughout your code to test things, to see if things are correct, if they're going your way, if you're confused. Don't blindly shoot in the dark. Put prints everywhere. Print your variables. Put print strings to see like and track where you are exactly. It will help you. It is a legit high-end debugging tool from beginner to top-end expert. We all use prints and other ways to log our code to see if errors have occurred correctly or because of our faulty logic. All right, any questions? The attempts were going down earlier, even though into the negative, but now it says it stays at 1. Would testing be the only reason you would put something after a break? No, you never want to put anything after a break because it will never run. I'm just saying for you, you can put a print after a break, or it doesn't have to be even a break. I'm just saying in general, you can put prints anywhere to help you debug and figure out what's going on in your code, because this can be not very visual sometimes. What do I mean by that? We have up to 50 lines of code here, counting all of the blank spaces too, and we're only seeing a couple things print out at any given time. It's not very visually feedback oriented, all right? So to get more of that visual feedback and to understand what's going on at any time, you can add your own print statements anywhere to track and see what's going on. Now, when you turn it in to your customer, it's going to be recommended that you either delete these or comment them out or make some type of dev mode for your program so they only will print or turn on or log when dev mode is activated. Don't worry about how to do a dev mode. We're not going to talk about that right now. Let's see. Any other questions? So let's go on to a little break. All right, let's go into a little break. I want you guys to mess with stuff during the break. All right, mess with stuff on during the break. We've gotten pretty close to having the game completed. All right, so I think it's actually in a completed state right now for V1. So look over it, mess with things, see if you can try to break it, test things, and put in any questions you have into the chat so we can answer them and go over any question you guys have before we move forward. All right, I'll see you guys in 3 to 5 minutes. Alrighty. We are back. Before we get back into it, you guys know the drill. Free stuff. Go get your free stuff. Go get the free sweater. Enter. Subscribe to the YouTube channel. Subscribe or follow the Twitch. Alright? And there's some other things you can do in here to get entries. Make sure you guys go do that. And if you want to help support us, because doing things for free is not cheap, you can go ahead and over to this link and donate and see me shave my head live on stream or teach for 24 hours straight, but definitely don't donate enough for me to shave my beard. When you donate, everything is being matched 1 for 1 for the first 10,000, all right, 10,000 buckaroonies. Additionally, you can unlock certain rewards, like our stickers, this epic collab t-shirt here, and our exclusive 100 Days of Rootkit sweater. Let me check the chat here and make sure there were no, if there were questions coming through or not. It looks like there's not. Alright, so let's get back to it. Before moving forward, look at this. Look at the code. Stare it in its eyes. Does it seem a little overwhelming? Does it seem like there's a lot going on here, especially on my screen? It does. Even to me, it's giving me anxiety. Alright. Comments. We went over printing for debugging. Alright. Let it be your guide. Use them all the time to see what's going on. Alright. But comments. Use comments to help you understand at a quick glance what's going on, but also reminding yourself just in case you forgot. So let's add some basic comments in here. Alright. So comments are totally up to you on where you want to put them and where you deem them necessary. I don't think this stuff needs any comments because it's just us making variables, but maybe this one does. So let's go ahead and leave a comment here called creating our mask, and it's gonna be as long as the selected word is. All right. Then here, this is our game loop. Our game loop will not end until attempts are 0 or if they won the game. All right, add comments to help you out here, kind of understand. Printing attempts left. Don't think that really needs a comment, but you can do whatever you want. Comments are free. They are free. They don't slow down your program at all. All right, let's see here. Printing out an underscore or a character based on the mask value. You can add more comments in here if you would like or not. This is going to be for guessing our character. This is going to be for checking if they gave us bad input. Let's see here. And for this, we're going to, this is for guessing correctly of a character. Guess. So, checking if they guessed a char correctly. And continue on like that. All right, use comments to help yourself from getting overwhelmed, because no one wants to be overwhelmed when they're looking at things. Also, it's easy for you to reference back and, you know, see what's going on and kind of remind yourself on what's happening. So this one is our logic for seeing if the game has been won or not. And this is for if they guessed incorrectly. If they guessed incorrectly, deduct an attempt. All right. Add more if you need more. All right. Like I said, they're free. You can have as many as you want to help yourself understand what's going on at a glance, future you will thank you, because if you have to go back and revisit this, this will easily remind you of what's going on. All right. Let's see if there's any questions. I fixed one spot, but something is still wrong. But I can go back later to go through each line and find where I messed up. Alrighty. If you have the error, you can post it in the Discord in the 100 days section, and we can help you out there. Alrighty. And any other questions? Does not look like it. All right. So, you guys ready? We know our game will end correctly now because of this, our win tracker here. I'm going to remove this print statement here because we don't really need that debug thing. So let's go ahead and rerun this. And our game is running through, so let's cancel this and do a clean run. A clean run. And let's see what happens when we do win. We put a P. We put an O. Looks like we left a debugging statement in, so that's printing out here, but that's fine. Process. Interesting. We have a bug because we've won the game, but it isn't ending the game. Even though we put our win tracker here, there's something going on. There's something a little fishy. So we should figure out what's going on. Why are things being a little fishy? Why is the game not ending? So how do we go about this? Well, you can start in numerous different places. It's totally up to you on how you want to go about it. So how do we want to go about it? Well, one place is the game should end if the win tracker here is set to true. All right, if the win tracker here is set to true. Wait, false. Hold on. So if the attempts are not, so this may be our culprit here. All right. Maybe we were wrong with the or statement because this would be true, right? No, this would be true. So while attempts not equal to 0. So this is going to be true, and this is going to be true when we go through. But an or statement will always try to go with whatever's true. So even though our win tracker here has changed, and they did win the game, this is still going to be true, and that's why we're getting our, that's why we're still playing the game. If we want to confirm this, we can print here at the top, we can print our win tracker. So let's just grab what we did here for attempts because we're already printing attempts. So let's print win tracker, and let's say win tracker is equal to whatever gets printed out here. So now we have a live status. This is all part of the debugging steps. So we have a live status of the win tracker. And if we see right here, the win tracker says that we're currently, it's currently false. We have not won the game. That's how it's supposed to be. So let's try to win the game here. So P R O C E S. Interesting. Our win tracker is definitely saying true right now. So that means we don't need to test or change this logic here because we know when this win tracker, we know this win tracker is working correctly. All right, we know this win tracker is working correctly. So that must mean, at least our next hypothesis is our while loop here, our while loop logic is incorrect. And if we look, it's because this is still true, even though this is going to be false. And an or will always go with whatever one is true. All right. So we need to change this to an and. All right. So that way they must both be true. And if either of them are not true anymore, then it will end the loop. What do I mean by true? I thought this was true. Well, that's right. It is true. That's why the not is here. The not is for us to do the opposite. So let's go and end this in clear after we made our little change here to and. And let's rerun it and do process. Look at that. The game ended. It says we lost, even though we didn't lose, because at the very end of our code here, we just have a little print statement that goes off. But we can add some logic for this, for checking whether we actually did lose or we actually did win, and then print an appropriate message. All right. But the main thing is we've found a bug, found an issue from playing our game, and we took little steps to try to figure out what was the issue. We used prints here to help us debug the issue, and then we solved the issue. All right. So we can go and remove this win tracker print statement here because we no longer need it because we solved our issue, and then we can continue forward. Alrighty, any questions on that? Use formatted strings with print. Don't use formatted strings with print attempts, and now you sell this code for $10 million. I don't mean, what do you mean by don't use, wait, don't you use formatted strings with, yes, you can do formatted strings like that, but this is a more elegant way, I personally believe, to do it, and that's the way we're going to be doing it. We're going to try to avoid shorthand as much as possible right now, because when you're learning, it can become confusing at times. You can totally do it the other way if you want. The big issue with the shorthand version, why I don't like it and prefer it, is that all your variables are now hidden in various parts of the string, and you have to go find all of them and change them later on, compared to them being all in one area, all at the end. So you can easily just go to the end, to the dot format, see all the variables that are being used, and edit them later on. They both work the same way, the shorthand and the dot format. They're just different ways of going about it, and they both work just fine. So you can use whatever one you seem fit. Yeah, that you can do either or. That's completely fine. It says there's no error, it just continues into the negatives. 2 bugs. Perfect. So you got a little bug there. That's fine. So you know that your attempts aren't ending the game. So maybe you should check your while loop. All right, maybe you should check your while loop right here and see if you have the logic correct to stop your game if it's looping, which sounds like you have the same bug I just had and I just fixed. So if you put this as an and, it should fix it. Because for example, if I change it back to an or in its broken state, when we won the game, things didn't end. But it will also work if we lose the game. It will not end anymore because of this or we have. So if I get something wrong, like M, and I keep doing M's, you'll see I'm now in the negatives also. All right? Because we have an issue with our logic here. Because even though this has expired, we're out of attempts, this is still true because we haven't won the game yet. So this is true because it's the opposite. If we're not winning the game, we want to keep playing the game. So because this is true, it will keep the game going since we're using an or statement. That's why we got to change it to an and. So it will break both sides. All right, it will break both sides. That's why you're experiencing that bug, Kauai. Can you scroll down? I'm trying to see what the continue is for. Yep, right here. So remember, the continue is to stop going forward or down with our loop and force the loop to go straight to the top from right here. So instead of running all of this code below, it's immediately going to send the loop back to the top. don't go down. I put my line of code as attempts equals -1. So the attempt logic, make sure you've built this in here somewhere, and that you don't have a continue in the wrong place. So our continue, we only added 1 here if they enter in bad input. So if you do have the truth tracker logic here, aka whether they got a good or a bad attempt, this might need to be moved around into a different place. So overall, this code that we're making is definitely in very complicated. We went 0 to 100 really quick. That was on purpose. All right. So you guys can get exposed to a lot of things very quickly because you're going to be receiving a challenge for you to make by Sunday. All right. You guys need to make a program by Sunday. I will reveal what that is at the end of today's stream. All right. So let's go ahead and chug along here. That fixed it. Awesome. Perfect. Let's chug along here because we're now successfully exiting the game when we lose or when we win. But right now we're always printing you lost. All right. We're always printing you lost. So we need to print based off whether we won or we lost. All right. Whether we won or we lost. So we have things here for whether we won or we lost. Our attempts and our winning tracker. Our attempts and our winning tracker. So if our winning tracker is true, this is good stuff. Let's go and write it. If our winning tracker is true, that means we've won the game. So we should probably just print you won. And technically, if anything else, then we lost. All right. If anything else, then we lost. So we don't even need to check attempts. All right. Because it's a binary system. You either won or you lost the game. There is no in between. So we can just do an else statement to catch everything else. All right. So if we won the game, we're going to print you won. If we lost the game, then we're going to say you lost. So now this should be a fully functional game. Let me remove this debug statement here before we move forward. All right, and let's go ahead and try this. All right, that was the last little piece to our game right here. So if we go ahead and lose the game, so let's do a Z and a Z, it says we lost. Awesome. Let's rerun the game and do process. And now it says we won the game. Look at that. We've done it. We've damn done it. We damn won the game. Our logic is printing here. And now we have a fully functional version 1 word guessing game. All right. The selected words here, because we have a hard-coded word. So before you would turn this into your customer, you'd want to change it back to the random word generation. But that would be like the last final piece here. That would be the last final piece. All right. Any questions on that? This is where you guys gotta go do a celebratory dance. What other questions? I just spilt water all over me. Let's go ahead and add a comment right here while we're at it. If we won or not. So what else here? There are lots of things we can do to improve upon this game, which we won't really get into right now. That's for another day. All right. We've successfully made V1 and we've made our customer very happy. We've got our 100,000 V-Bucks now. All right. We got our 100,000 V-Bucks and we're good. Things, again, I guess the selected words in your attempts here you're going to want to alter in order to make the game more normal. We don't have our actual dude printing out and being hung, all right? So that's something we could add. Saving is something we could add. Scores we can add. So there's a lot of things we could add on, but we'll see what the customer says, all right? Any questions so far? Anything that you guys want me to review in this code? Anything that doesn't make that much sense? Or maybe you did it in a different way and you want to show it off. So while you guys ask your questions, this code showed you guys a lot of things, a lot of new things. I guess not so much new things, but a lot of ways you can combine things together. The things that we've already shown off, your basic tool set. The basic tools are very simple. Strings, ints, lists, while loops, for loops, if statements. That's pretty much it. And I guess there's functions. Those functions are just actions you got to remember, and they vary everywhere. But it's all about how you kind of start thinking about how to put all these together, right? Thinking about how you put all these together. So this really, I think, shows off how you can go about thinking, taking one little bit at a time and tie these things all together. Remember, for games, we always got to have that while loop. There's many different ways you can go about analyzing and printing out characters and doing your matching. User input, remember, it's always going to be a string. It's always going to be given you a string, and you have to filter the user's input yourself. All right, there is no help in regards to that by default. All right, you got to do it all manually. You're in the programming world now. It's all raw. All right, it's all raw. Let's see. Any questions that have rolled through? Here we go. Got another bug adding. Oh, you fixed it? Perfect. Epic. That's what I like to hear. Fixing and finding your issues. That is perfect. That is the programming way. All right. That's the way of the programming Jedis. You got to find those issues and go about steps trying to figure it out and debug things. Make it work. Flagging. Flags. All right. Trackers. Flags. Whatever you want to call them. Very useful. You can have them. You can have as many as you want. You can have an unlimited amount of them. All right. You can make flags. Let those be the way that you solve things. Now, where you put all this stuff is very, very important. All right. I kind of put everything exactly where it needs to be, but you may not have as much luck your first go around, and that's okay. Let me see here. Well, it's also printing a ton of true lines, so I'll have to figure out where that is happening. It's good. Hey, it's helping you debug and figuring things out. So that's the most important part. So let's see here. Your guys' challenge. All right. So we got a challenge, and then also what I need you guys to do before tomorrow, because we're going to be moving forward whether you went through it or not. I don't have time tomorrow to wait for you to make an account on this site. So make an account before the stream tomorrow. Make an account before the stream tomorrow. I'll get to that one in a second. Your guys' challenge up until Sunday, all right, up to Sunday, is I want you guys to remake this game from scratch. I want you to make a new file and make it all from scratch. Don't look at this file. Better yet, delete it. Delete this file and try to make it again from scratch. You'll see that you're going to struggle a lot. That's fine, right? Think through it. Go bit by bit. Don't look at it. Unless you are completely stumped and you don't know where to go forward, then you can refer to it, obviously. But try to get as far as you can. Try to get as far as you can. All right? Remake this thing. The second thing is, if you haven't already, you need to, before we go further, you need to make a GitHub account. You need to go over to github.com and you need to make an account. Tomorrow we're going to be introducing Git. All right? We're going to be introducing Git and how you can use services like GitHub and GitLab with your local Git and push things, commit things, pull things, etc., etc., save your code, versioning, publishing, etc., etc. All right? Because this is how the customer wants you to turn things in. So we need to do this. Make an account on here before tomorrow because I don't have time to sit here for everyone to make an account. All right? Make an account. On top of making an account, please download GitHub Desktop. All right, GitHub Desktop. This will make your life easier. I'm going to put in the 100 days of Rootkit chat. Download this. Make sure you are logged into your account on GitHub Desktop if you're not already. All right, complete all this. The final thing, GitHub Desktop should include it, but just in case things are weird, download Git. All right, there's a button right here. This thing, download it. Install it on your computer. It's in the 100 days of Rootkit chat in the Discord. So do both of these. Make an account, download GitHub Desktop. Also, download, install this just in case, because I think, if I remember correctly, you still have to do this step regardless. So do those things. Because we're going to get into Git and versioning control. It is a necessary tool for you to learn. So we got our VS Code here, which is our text editor. It's basically as if we were novelists and we're using Word, right? Microsoft Word. This is going to be our special file system, how we're going to store our code, our documents, all right, and versioning of those. You know how you're used to your phone and your apps, etc., they have version 1 and 1.1 and 1.2 and how they keep track of all that. Do they copy their code and put it into folders and keep track of all the folders? Well, kind of. It's a little bit more sophisticated than that. It's called Git, all right, and it's a program that will do a lot of that for you. So go get that stuff downloaded and we're going to learn about it tomorrow. Alrighty. Should we download? Yes, download both of them. Download both of them and install them because I'm pretty sure GitHub Desktop is not going to install Git on your command line. How you can test this is if you go to PowerShell or CMD, and if you type in Git, you should see a big help menu print out like this. If you download GitHub Desktop and you type this in and it works automatically, then you're good. If you don't see that, then also install Git. Also install Git. All right. Any other questions before we end today's stream? So while you guys' questions roll in, again, recap. Remake this program without looking, right? Without looking. Remake it. You can look at all of the other days' code. All right, you can look at all of the other days' code. Just don't look at the word guessing code. Try to remake it, or at least try to get as far as you can by Sunday. Drop your code in the 100 days of Rootkit chat, and we'll take a look at it. All right, and we'll see how you guys did. Second, prepare for tomorrow. Download GitHub Desktop, make an account on GitHub, and download Git. All right, the links are posted in the Discord. Should we make it a new word too? It's totally up to you. I'll just Google questions before looking back at the code. Yeah, make sure you guys Google. You can use Google. You can use literally anything you want. You can use all the previous day's code. Just try not to look at this code as a last resort, all right, if you have to, but try to figure it out. If you get stumped, try to get out of that stumped state, because you will be like that in the real life. You will hit barriers like that in real life when you are programming on the job. You can't just look at some reference code. You need to figure it out. So train yourself now, test yourself now to see if you can resolve those issues. Should we make it a new word too? Yeah, you can do whatever you like. GitHub desktop is GitHub. It's going to get access to your GitHub account. Additionally, GitHub is where you can, you can do this, but no one really cares. No one's really looks at your GitHub for resume usage. It's very, very rare if anyone does. But you can post code to your GitHub profile, and you can, show it off to the world. No one really looks at it though as like a resume, so you're not really gonna wow any people by doing that. The best thing for doing this would be is if you made libraries or useful tools for people to use, then people will be looking at your account and so forth and checking up on what you're doing. But when you're not, then don't be in the unrealistic expectation that apparently a lot of basic devs are using GitHub, that it's going to be some epic resume builder that's going to get you a job. It's not. No one cares. No one looks at it. I've done recruiting for multiple different companies. We never ever spend the time, and lots of jobs you apply for will never care. It's been on my resume. I've applied everywhere. I've interviewed everywhere. Google, Microsoft, Tesla, SpaceX, etc., etc. They will not look at it. They don't care. All right, because guess what? Programmers are lazy. That's extra work. Also, no one cares at the end of the day because they have their own tests and quizzes they'll facilitate to you live on the job to see whether you know what you're doing or not. Not to see if you might have or not have copy and pasted code and uploaded to your GitHub. No one cares about it. Use it as a training ground, because everyone in the companies that you will work for will be using Git in either GitHub or GitLab for version control of their code internally, right? That's where it's valuable and that's where it's important. All right. I don't see any other questions being rolled in, so I'm going to guess you guys are good. If you have any other questions after the stream, drop them into the Discord. For the people that are watching these YouTube videos afterwards, drop them in the Discord. Tomorrow we're talking about Git, and that's all I got for you guys today. So I'll see you guys on the next one.